this happened. I didn't share any details. And the reason is Wi-Fi is ubiquitous, right? So it's you can expect this to happen anywhere in the world today. I'll just take you through some data which bolsters my point, right? So over the years, what we have seen is that the average number of clients that are connected to an AP has grown from maybe about 10, and then it moved on to 12, 15, and now it's close to 20. And what we are also seeing is 5 gigahertz is as much used as 2.4 gigahertz. This was not the case even a few years back, like in the late 2010s, 2018, 2019 timeframe. 2.4 was predominant. Now we are seeing that it's roughly the same. The availability of dual band phones in affordable price ranges could well be a contributor for this. We're also seeing back randomization quite a bit. Apple started the trend, and now Android and many other devices are also following the same. Why it's significant is we have some problems as an operator because of back randomization. I'll not go into that now, that's for a different session. And on an average, every single day, we have 140,000 terabytes of data that's exchanged over Wi-Fi across all our Wi-Fi access points in India. And just to take off on the previous session from Ms. Charumati, so the point about the fixed wireless devices in rural areas. So I have a counterpoint to that. So it's anecdotal, but maybe revealing as well. So from some of my colleagues, I have learned that in some rural areas in big farms, our devices are indeed getting used for connectivity. So that's the good side. There is a flip side as well. This is data from UK, and the highlights are there, maybe the lowlights. 80% of customers have complaints, and this is a problem which every broadband service provider and internet service provider in the world grapples with. And I've basically put together the complaint category, and 60% of complaints are related to Wi-Fi. There is problem with suboptimal throughput, frequent disconnections, slow speed, router problems, downtime which extends for hours and sometimes even a full day. So that is the split, and this is so bad that 20% drop in customer loyalty is seen when there are so many issues. This is the story in India. The trend is pretty much the same. This is complaints mainly, and you can see about 80% of complaints are indeed related to Wi-Fi. There is a little bit of nuance to this. I'll come to that later on in my session. Now we'll do a deep dive into some of the most common and prevalent issues. So the first one is poor range. So as Wi-Fi experts, you'll all know that the design of an AP, there are several factors inherent in it which determine what would be the range and coverage of an AP. The industrial design itself, the number of antennas, whether they're internal or external, and the orientation of the device, whether it's vertical or horizontal. So all of these play a part. What we've seen in customers' home is the placement is also a key factor. We've seen customers who place their APs in the attic, beneath the sofa. They've kept it locked inside a cabinet. They have valid reasons to do so. Their power socket is at a place where they can only keep it at that point. They have other devices, so they can't move their AP around. The fiber to their home is basically landing at a place. Maybe attic is the only place where they can put it, and they don't want to draw Ethernet cables to any other place. The ideal place, of course, inside a home to place an AP is a center, so that all rooms get coverage. But that's not always possible. So customer places it at the farthest corner in their home, and the diagonally opposite room will not get coverage. The number of walls is again one more factor which plays a which has a significant impact, right? And in India, we use concrete walls, and unlike in Western Europe or US, where you have walls, dry walls, or those made of wood, the attenuation of the signal itself happens quite a bit because of concrete walls. So these are all factors that we have seen with respect to coverage and range. The next problem that we have seen predominantly is with respect to interoperability. Wi-Fi has grown over the years. There have been multiple generations, and with each generation, there have been improvements as well. But India is a vast country, and there are so many customers who use a multitude of devices. And these could be something that is provided probably by their organization, which is maybe an old device, and the driver in the device wouldn't have been updated for a bit, and all of that. The APs are themselves updated, both in terms of technology as well as firmware. But even an AP with the most recent firmware will not be able to service a client which is not on the latest technology or firmware. An example, a client which does not understand what channel switch announcement is will suffer disruption and have connectivity problems. We have had to also turn off fast BSS transition in some cases because clients did not know what to do with it. And there were complaints from customers because for them, their connectivity was not proper. In order to address problems with range, what we had also evaluated was easy mesh. For us, it was a big draw because it was supposed to be interoperable, and whatever be the systems we use, like we had seen in Mr. Mayur Sorode's presentation earlier in the day, different SOCs basically have their own solutions. But the promise was not fulfilled. That was our experience. So there were solutions from specific SOCs which did not play so well with other SOCs, and with that, we were unable to do much even with easy mesh. In some cases, it was so bad that the basic Wi-Fi experience of the customer suffered even when they did not have multiple access points in their home. And we had to take the decision to turn off easy mesh altogether. So those are some problems we've seen with interoperability. The third category of issues we have seen is with respect to the environment. Now, in India, and particularly in the case where there are apartments used, the density of APs is quite high. This brings problems of co-channel interference and adjacent channel interference, and not much can be done about it apart from trying to change channel and some other common mitigation strategies. Again, referring to Mr. Mayur's presentation, he brought up the point about coexistence with LTE band 40. So this was a specific issue we had seen where the AP determined that there was interference, and then it did whatever defensive actions that it had to take. But when it came back up after executing those actions, the channel calibrations could not be applied fast enough. And because of this, again, the customer's connectivity suffered. And one other problem we have seen is that the Wi-Fi subsystem suffers from the overall heating that happens in a small enclosure. Again, I'm sure you all are aware that there are those defensive mechanisms where there is hysteresis and then maybe the subsystem shuts off. But then when it comes back up, we had a case where the data path was not established correctly, resulting in poor customer experience. In a few other cases, we have seen that customers used a power adapter which was not provided by us. And so the rating of the power adapter itself, the power supply basically, so that was so low that the Wi-Fi subsystem did not even boot up. So these are some of the issues we have seen with respect to the environment. And while the ultimate fix is within Wi-Fi on the device, the environment plays quite a significant part. Another notable thing with this is that these issues are very tough to investigate. And that's because no amount of logs that we can collect is going to tell us what exactly is playing a part in the environment. At the peak of lockdown, for a customer in Bangalore who had complained several times about having issues with their Wi-Fi, we had to deploy a technician in the customer's home for 3 consecutive days. A technician sat in the customer's home for multiple hours, and only after that could we actually determine that there was some problem with their environment. The final category is related to the Wi-Fi clients itself. And here we have seen quite a few. iOS, with its focus on privacy and security, frequently tells that our network is not secure. And in some instances, iOS has also tagged our APs as a hotspot. There was some IEs which iOS detected, saw that for it to classify the AP as a hotspot, when it was not. It was being used in a home environment. Customers bring clients or Wi-Fi devices from other markets, and this also results in problems. There was a case where a customer brought a desktop Wi-Fi adapter, probably bought on eBay or Amazon with some driver, and then it was not at all working well with our APs. And in another case, an Amazon Fire Stick, which customer got from US, and on an AP which had channels 12 and 13, particularly with channel 12, it was not working and the customer complained. So these are, again, some issues we have seen with particularly with clients. Now, I referred to a nuance earlier in my during the first few slides. So the point is, not all of these issues, even though they are raised by the customer as related to Wi-Fi, are indeed related to Wi-Fi. There is quite a bit of misappropriation there that happens. Again, some examples come to my mind. So while we were doing validation internally, our test team kept complaining that Wi-Fi is not stable, and they were pumping traffic, trying to do stress testing and all that. And what we realized was that there is an Android app which basically flooded the entire local network with packets, and then that made the whole network unstable. This had nothing to do with Wi-Fi, but even the test team still told that this was a Wi-Fi issue. In another case, there were some IoT devices, maybe a smart bulb or a smart switch, which could not handle IPv6, and because of that, the connectivity did not happen, and even that was something which was tagged as a Wi-Fi issue. Moving on to the mitigation strategies that we have applied. So heat map analysis is something which we use. It's a common practice. So in order to determine what could be an ideal placement, we have a tool that detects the hotspots and dark spots in a customer's place and suggests an ideal placement. We do quite a bit of telemetry collection in the form of data counters, signal strength, and error statistics. This is then fed into our machine learning model, which crunches the numbers and then comes up with some predictions. And as a reactive or responsive measure, we also provide quite a bit of controls and knobs through our remote management tool, which can then be used to change the Wi-Fi settings and configurations whenever a customer has some complaints. Again, To take an example, when a customer had 11B only client, we had to change the AP band to 11B so that the customer's connection could be restored. Shreyas Iyer got injured recently, right? And he will go through rehabilitation, possibly in the National Cricket Academy. And during that, I'm pretty sure that he will undoubtedly practice short pitch bowling, all his hook shot and pull shot. But once he's back in the team, he's in Australia facing Mitchell Stark. It's a whole different ball game. The analogy is the performance or behavior of Wi-Fi in the lab is quite different from what you see in the real world. I'm aware that I'm talking to a room full of Wi-Fi builders, and I've tried to bring in the perspective of a Wi-Fi user. Whatever I have highlighted here, I hope that it could provide you some insights when you're building the solutions. Thank you.
Yeah, that was a great turn. We can start a Q&A session. Yes. Just curious about your Easy Mesh experience. You said that one was the multiple AP case where you had some issues, and then even a single AP case you had an issue.
Yes.
Is it because of the Easy Mesh related overhead that might be on the AP? Because there are no client related issues, I presume, with Easy Mesh.
That's true. So whatever we had seen was that uh, the way the solution was designed was that a single AP solution and a multi-AP solution were different, right? So there were more processes which were running when Easy Mesh was on. So something for the 1905 or for the multicast and all that, and that basically played a detrimental part with respect to even the single AP conditions.
Hi, I'm Srinivas Boypati from HP. So you were explaining the Wi-Fi signaling problems and the connectivity problems. So during we actually qualify our product like printers. So what our observation is like the issues that we are seeing, some of them are related to the low-end routers that are being provided by the ISPs. So, so since you are from Geo, I just wanted to know what is the criteria that you follow to actually select the AP when you are trying to provide it to the customer.
So cost is obviously one factor, right? So, but we do not work with, or I would say we rather work with the top tier silicon providers. So we work with the leading Wi-Fi solution providers. But like you saw in the first presentation, apart from the Wi-Fi SoC itself, all the other factors like the LNA and PA, those also play a big factor, right? So the choice of those, along with whatever is the Wi-Fi SoC itself, so that is quite crucial. So there, again, there is a reference design from any of the SoCs, and then there might not be too much flexibility with what we can play around with, right? So if from the SoC point of view, they have qualified, say, front end module, then pretty much our choices are also limited. But apart from that, overall, what we also have is our own product quality in terms of the RF and overall hardware, the mechanical characteristics and all that, which are evaluated. More often than not, whatever the main SoC brings to the table uh, with respect to whatever are their offerings, like typically they have for multiple segments, something which is targeted for the lower end segment, something which is the mid end, and then the high end, right? So it would depend on, again, what market segment we as an operator want to target. But overall, there are processes in place which, right from the selection of the chipset and the overall reference design, and then the selection of original design manufacturer, and then the firmware, and all of that are, there are processes in place to check all of that.
Okay, so in the interest of the customer, right? So you are telling the interoperability aspects, right? So is there any qualification that you do, or you partner with the customers?
Yes, yes. So we do have interoperability and list of mobile phones and popular devices with which any of our access points would need to work well with. And this we also share with our system on chip partners at the earlier stages, even before it comes to a later stage when more features are added, or solutions are developed on top of a platform. So this is something which we provide to them. In some cases, there will be a like to like model in the country where the system on chip suppliers do their testing, but that might not always be possible because there are the phone manufacturers, they pretty much also have models specific to India, right? So mobile phones, yes, we have that kind of a list, and then other popular laptops and all as well. When it comes to some of the lower end devices like IoT sensors and all, that is not something we are doing yet, but probably we'll have to plan for those as well.
Thanks for the presentation.
Okay. Sure.
Yeah. One last question from. Yeah. Yes. We can take it like as a time constraint. Like. Yeah. Thanks for the presentation. Now that the 6 years that has been opened up for low power, was you plans for bringing in 6 GHz to homes? Are there any R&Ds going on?
6 gigahertz, yes. Like there would be that kind of a deployment happening, but I don't have a timeline as yet.